Hello, welcome back. In this video, we're going to go through another application of differentiation. It's called the first derivative test. So our function is 8 minus x times x plus 1 squared. So we're given three sub-questions. In the first one, we're going to find the critical points. And in the second one, we're going to determine the increasing, decreasing behavior of the function by using the test for increasing and decreasing functions. You can check that test in the lecture notes. And eventually, we're going to apply the first derivative test to identify relative extrema. And just want to remind you what the first derivative test is. So let's try to read the statement here. So let's say we have a critical number c, and the function f is continuous on an open interval containing c, and as well differentiable on the same interval, but not necessarily at the critical point. Then you can classify f of c in three different categories. So the first one is that if f prime changes from negative to positive at the critical point, then f should have a relative minimum at c and f of c. So here we go. So if f prime is negative on the left of c, which means f is decreasing, and you hit the critical point where you have a horizontal tangent line here, and then on the right f prime is positive, and that means the function is increasing, so c f of c becomes a relative minimum. Okay? And in the second case, you have f prime changing from positive to negative at c, so then we have a relative maximum, and here we go. F prime is positive here on the left of c, and negative on the right of c, so that the function makes a relative maximum at that point. And in the last case, f prime could be like just positive on the left and the right of c, or negative. Then in that case, there's no conclusion. While in that case, the function is increasing all the way regardless of the point. As you see, it keeps increasing, so there's no relative minimum or maximum, and same way for decreasing functions all the way on the left and on the right of c. So in the next slide, we're going to see how this test is applied to the given function. All right, first we have to find the critical numbers, and we know how to find the critical numbers. We're looking for x's for which f prime is 0 or f prime undefined. So we have two different types of critical numbers. But for both of them, we need to find f prime. And to find f prime, we should probably use the product rule because we have the product of two functions here. So let's apply the product rule real quick. So we have the derivative of the first function, multiplying the second function, plus the first function times the derivative of the second function. All right. So the derivative of the first one here is negative 1, so this becomes negative x plus 1 squared. And the derivative of this one is found by the chain rule. The outer function is the square function, and the inner function is x plus 1. So the derivative of that, carrying forward 8 minus x, is 2 times x plus 1 to the power of 1. Okay, that's the derivative of the outer function. And times the derivative of the inner function, but the derivative of x plus 1 is just 1, so it's just times 1. So first critical point comes out of setting this equal to 0 and solve this equation for x. And not to mention the second critical point is the one that makes f prime undefined, but f prime description is here, and there is no x that makes this function undefined. So it's in fact defined everywhere. So the only critical point that we can come up with is going to come out of solving this equation. And how do we solve this equation? Well, we can add x plus 1 quantity squared to both sides of the equation to get x plus 1 squared equals 2 times 8 minus x, x plus 1. And this is a good exercise for you. Why don't you expand the left-hand side all the way and the right-hand side all the way to get two quadratics in each side of the equation, and probably subtract one quadratic from one side of the equation to get only one quadratic. So let's do it. All right, this is what you get after you expand out left-hand side and right-hand side. Why don't we subtract this whole quadratic from both sides of the equation? And this is exactly what we get after we subtract this term, this quadratic, from both sides of the equation. And now we have a quadratic equation to solve. Here's another exercise for you that you can just work by yourself. Apply the quadratic formula to this equation. Okay? You're going to have two different solutions. One comes with the plus sign, the other one comes with the minus sign. And in fact, those solutions are x equals -1 and 5. Said these are the only critical points for this function. So in the next step, we're going to go ahead and determine where the function is increasing or decreasing by applying the test for increasing, decreasing functions. And here we go, and I have this table for you. So we don't have an interval provided to us in the question statement. So for that reason, I chose my interval to be -infinity and +infinity. All right, so I have three subintervals: -infinity and -1, -1 and 5 and infinity. So we choose sample points from each interval to determine the sign of f prime. So my sample points are -4, 0, and 2, and you can choose your own sample points. It's up to you. So for those chosen sample points, I'm going to look at f prime evaluated at -4, and here f prime evaluated at 0, and f prime evaluated at 2. You can go ahead and punch in this function with those x values one by one and determine the sign of f prime at those points. And turns out that the first one is a negative number, and this one is a positive number, and this one is a negative number. And here we go. So this is the cleaner version of what I did in the previous slide. So since we have the sign of f prime negative, so the function is going to keep decreasing on this interval, and the function is going to keep increasing on this interval, and the function is going to be decreasing on the interval 5 and infinity. So what that means is the behavior changes from this interval to this interval at the junction point, which is in fact the x-intercept for f prime. So what that means is you keep decreasing and decreasing all the way up until you hit x equals -1, and then you start increasing. So then we should have a relative minimum. And likewise, you keep increasing all the way, you hit the junction point 5, and then you start decreasing all the way. So we should have a relative maximum over there. And here is the graphical outlook for the function 8 minus x times x plus 1 quantity squared. Remember that -1 and 5 were the critical points. At those points, f prime was 0, so we do have horizontal tangent lines at those points. And as we concluded from the table that on the left of -1, the function is decreasing all the way. And we make a flat tangent line here, and then the function starts increasing all the way up to the next junction point where you have the 0, where you have the horizontal tangent line. And then the function keeps decreasing on the right of the critical point 5. All right, our table is verified by the graph of the function, which makes the end of the video. Thanks for watching. I'll see you in another video. Bye.